focusing. I was actually quite sick last week, so things weren't quite as well coordinated as I'd hoped with getting everything together for this. So the presentation I'm giving is going to cover work with a lot of collaborators over the years, and really I probably should call the talk Developments in Understanding the Formation of Gold Mineral Systems in the Yilgarn, and as John Walsh highlighted in his talk. You can't hear this? Need to get closer? Right on that. Okay. So as John highlighted, there's been a lot of collaborators over the years. I've worked in the field with John Walsh and others over the years. So what I've tried to do is to synthesise some of our recent understandings over probably the last decade on the gold systems in the Yilgarn. Cam gave a presentation on the mineral systems model. Today I'm really going to be focusing on sort of the regional to deposit scale. John Wronski's actually giving a presentation after this on some new insights into deposit scale ore shoots. So I'm going to steer away from that in my presentation, and he'll be able to step into that in his presentation. Look, there's been some really big controversies in the Yilgarn. The crustal continuum model of David Groves was a big one. Can people hear me clearly? Yeah. And that was a lot of research work at UWA, headed by David Groves, and it was attacked quite strongly a couple of years ago. In my view, I think that model still holds up to middle and fieldlight facies, and that's really a whole other presentation. There's been a lot of argument about the role of intrusives. So one of the questions just then is porphyries linked to mineralisation. So I'll address that. And linked into that is arguments about distal versus proximal fluid models for the deposits. You've had arguments about mantle versus crustal sources of fluids. And indeed in the crust, people argue about meteoric. Doug Haynes, Van Olympic Dam would argue it's all circulating in brines at shallow levels. People like Neil Phillips would argue that you've got a metamorphic fluid source, and then other people argue for the mantle. The timing of gold mineralisation has been a massive argument. Event histories. Most people here would have heard structural geologists arguing about their deformation events. My D3 doesn't exist, your D3 doesn't exist, and my D2 is really your D4. The role of fluid mixing, which was talked about in the previous talk, and indeed using fluid mixing proxies in targeting. The role of fluids driving the systems and the sort of insights you can get into ore shoot formation, which John will be talking about after this. Source of the gold, another big bugbear. The role of early architecture in relationships to complexity, and also geodynamics. Buoyancy-driven diaprism versus, say, plate tectonic models. People saying, oh, the Archean is a little bit hotter, and you have just slightly different plate tectonics active, whereas people like Martin Crenadont would argue, no, it doesn't exist. Having said that, I did say the last 10 years, but there has been sort of over 30 years of intense research into these gold systems, and David Groves, who was head of the Centre for Global Metallurgy and previous centres before that at UWA, actually gave a talk at the CD Discovery Day this year, and he actually summarised what his 10 commandments were for finding orogenic gold deposits. So for those of you that are new to gold or just starting your careers, there's a few young faces here, I'd reckon if you want a copy of that presentation, we can send it, but it really does cover off some of the main empirical things that you need to find world-class ore bodies. And this was cut straight from his presentation. Widespread gold anomalism, discrete low-strain belts. You don't want wide zones of shear zones that go forever. Anticlinal zones, competency, compositional contrasts, big crustal and lithospheric scale shear zones. You notice I put a red mark next to that. One thing that's happened in the last decade is we've got much better at imaging these. There hasn't been any talk about the Capricorn origin, but there's a big project there putting big passive seismic arrays out. There's there's an active seismic line that's been put in. There's MT surveys going all over the place. There's regional geochemical transects occurring, and there's even a new airborne EM survey that's come out. So we're actually getting much better at imaging those boundaries. And indeed, through time, if you do some of the lutetium hafnium work that's been done by people like Kevin Cassidy and David Mole more recently. Prominent jogs, corridors of oblique faults, complex granite contacts, more complex geometry at sites of deposits, and of course a supportive board, good management, skilled exploration team, and still some good fortune. And a lot of these things still hold, right? So if you're just looking for empirical constraints on mineral systems, these are not a bad set of 10 things to be looking at and thinking, have I really got all these elements in my field? Today what I'm going to do is present an overview of some research results from places like Jundee, Laverton and St Ives. That's, for those of you that don't know where they are, the locations are shown on that map just there. The figure originally was from a paper by Robert et al. 2005. So when did it all start? Well, the onset of major gold mineralisation is really linked to a switch in magmatism, which Champion and Sheraton have documented quite well, with the onset of mafic and cyanitic magmatism. And mantle-derived intrusions are indeed a key component of some genetic models for gold mineralisation. There's a switch to the formation of the things called lake basins, like the Marugal beds, the Wallaby basin. And as John pointed out in his previous slide, some people even have those basins as sources of a reduced fluid that can interact with oxidised fluids coming from the intrusions. The majority of the geochronology does indicate that gold is major, the post-peak of the mafic series magmatism. Having said that, a lot of the work has focused on proving or disproving a particular model. Okay, so there's been very, very focused geochronology in terms of what it's trying to achieve, and I'll show some examples of that in a moment. And the link to intrusives is mainly based on geochemical arguments. So John Walsh just answered that yes, indeed, when you look at your porphyries, generally the gold mineralisation overprints them. So a lot of the arguments for people to link mineralisation to linking gold to the intrusives is mainly based on geochemical arguments. And I'll show you two papers in a second that highlight that. So this is a figure from Bloor and Chanotta in 2007. It was from a Cal 07 conference. They then produced a paper in Precambrian research 3 years later with the reference given. Now I've used the older one because their new paper it's massive, it's like an A3 fold out. So this is a really good synopsis that really synthesises a large amount of research by multiple groups. I mean, there's sedimentology and dating by people like Brian Capez and Rick Squire, a lot of work from Cassidy and Champion, lots of structural geologists arguing about event histories and things like that. And what I've highlighted there is your standard stratigraphy. So here you can see London basalt, ultramafics, you're going into, at the top, your Paringa sequence, and then followed by your black flag beds. And then there's a major discordance with the formation of what they call the lake basins. And the Wallaby deposit, which is world class, is hosted within that particular basin. And if you have a look at this central part of the figure, the onset of these basins also correlates with, if you look at the magmatism, there's a mafic series of intrusives. It also correlates with this peak of mafic magmatism within the system. And right after that, on the far right, with the yellow box, is sort of all the published ages, xenotime and rutile ages and things like that, on gold mineralisation. And as I said, what you can see there is that a lot of those published ages actually do post-date the peak of this mafic series magmatism. Having said that, a lot of people are relating the mineralisation to the mafic series intrusives. So, where has this led us to, these relationships? Well, to summarise it off a paper by Cellier quite a few years ago, what I've got there is the proximal and distal models for gold for Laverton. In one model, you have basically a continuum model where you have a deeply sourced fluid that could either be from meteoric or from the mantle, and things like mafic series intrusives are just another host rock type. All the intrusion does is act as a rheology contrast, and that is another way of focusing the fluids to make a deposit. In the case of this work, and there's papers by Mueller on that for Wallaby, and in that argument what you have is a proximal fluid source from these intrusions, and you have a direct link to the mineralisation. If you look in the top right, that shallow basin there is meant to be coming out of one of the lake basins. So in this model up on the right, the argument is you need to be near a lake basin because that's a source of reduced fluid, and you need to be near one of the mafic series intrusives. There's a paper by Davis et al. And others have also argued that the mafic magmas might have actually been a primary source introducing the gold into the system. So you bring the gold in with that phase of magnetism and then you basically rework it over multiple events. So big argument and big differences in the models. And this incidentally is for Laverton, which is where Wallaby and Sunrise Dam is, and you've had very similar arguments at St Ives. This is from a paper that John Walsh is a co-author on by Newmar et al. And what they've argued there is you've got an porphyry at depth. Sorry, there's no pointer that's going to work on both, I don't think on that skill. And here what they're saying is the red dots are more oxidised, and where they have structures coming up, you have gradients between reduced and altered fluids, and those zones where you have the right structure and you have the alteration gradients is where you make the deposits. Contrast that with work by Paul Hodkowitz, who did his PhD at UWA, and he's argued that that's not the case, and that the different oxidation states can be linked to a bunch of... the fluids are originally from a single ubiquitous ore fluid that was modified by a range of processes. For example, fluid unmixing, making the fluids more oxidised, right? So quite diametrically opposed arguments within that particular deposit. Now here's a real killer in all of this, is that the timing of these fluids is very rarely constrained, right? And the dating of the different alteration metamorphic phases is a key requirement. And in general, even relative timing and overprints in hand specimen and drill core has not really been done. So it just gets presented as a 3D model of where the alteration types are. Having said that, if you're dealing with RC drilling and things like that, it's pretty hard to define overprinting relationships in those features. So where are the papers that link examples of intrusive, the intrusive phase and also the mafic phase and also the mantle to gold? These are the two main papers that I certainly would look at. There's a paper by Mark Kendrick, and it's getting pretty hardcore. It's noble gases and halogens, and that was on the St Ives goldfield. And another paper out last year in geology, looking at multiple sulfur isotopes, was arguing for a magmatic origin for Archean gold deposits. And that specifically did deal with the Wallaby deposit, which we'll look at in a moment, and the quotes there are straight from those papers. So the most recent paper on this work is the geochemistry they had is the isotope work is consistent with the auriferous fluid originating from a felsic magma or a mantle source, and inconsistent with the metamorphic and meteoric fluid hypotheses. Okay, so when John answered his question about do you see deposits that are the same age as the intrusives, and he said no, they're overprinted. This is a major argument against linking that big phase of mafic magmatism to the gold. And in the end, a lot of this does come down to field relationships and geochronology. Having said that, are there examples of deposits? Actually, yes, there are. Right? So the best example that I know of, out of 10 years of work, where you see a very clear timing linked to a set of mafic series intrusions is Jundee. Right? That top right photo is probably I don't know, but it could be the world's most expensive split set. That's actually a gold vein in the wall. So it's about probably 2 inches thick. And it was an oblique gold vein actually intersecting with the wall. Bottom right, you can see some really unusual textures. So you've got a breccia with coliform textures, and the grey is actually arsenopyrite. So very high level processes and lots of visible gold. In the middle here is actually a pit map from a paper by Chris Yates. And the dark grey unit is a dacitic porphyry that's mafic. And you can see the black lines of the lodes. And then what you can see cutting through it is a granodiorite porphyry, porphyry cutting through the mineralization. So what you see is a phase of magmatism that's mantle derived. The lodes overprint that, and then you overprint it with another set of intrusives. So the deposit, in effect, is bracketed by those mafic series intrusives. That's just a pit map. Here's an example from underground. You can see this granodiorite body coming through, down through like that. There's a close-up of it. You can see this lode, which is strike slip lodes. Everyone who's ever looked at it has argued that. And basically you can see this massive dike just cutting straight across it. In fact, it actually feeds out slightly into the actual 620S lode there, which is actually from the Invicta ore body. These dikes have been dated, and the age on those, the current accepted age is by Baggett et al., and that's 2657 plus or minus 6, so the deposit is older than that, right? So there are examples of old deposits that are coeval with the mafic series intrusives. That's not in the literature. If you read the latest paper in economic geology on that deposit, it will tell you the mineralisation post-dates the granodiorites. Okay, let's look at a few other areas. This is the Laverton area, so we're looking at moving up into Laverton here. Many of you would have seen this figure before. I've actually got oldest at the top and then youngest moving down, but this is basically a space-time diagram that was I produced years ago for the Laverton area, and what it shows is Wallaby, Granny Smith, Sunrise Dam and Jupiter. And what you can see on the left is a series of intrusives that have been dated, and the purple ones, the blue one here is mafic series intrusives. This is generally the older suite, which Champion called the high calcium series. This is the low calcium series. You can see here, this is the switch in magmatism between the two, you're making the deposits. What you need to be aware of is that there's multiple phases of gold mineralisation in these deposits. So you have an early phase of gold sin, the formation of the Wallaby conglomerate. I highlighted in that first diagram that Wallaby sits within a lake basin, okay? There's actually ductile shears within the Sunrise Dam deposit that are mineralised. Then you see a phase of basin inversion where these younger conglomerates and sediments, other sediments at Wallaby, get inverted. There's a phase of gold, which is associated with BIF-style mineralisation at Sunrise Dam. There's also gold mineralisation at Granny Smith. And then what you see is a really strong phase of mineralisation linked to the syenite body and, at Wallaby. And this all then gets overprinted by a phase of, for want of a better word, orogenic gold mineralisation that is not the same age as intrusive, but it has exactly the same kinematics at Wallaby and Sunrise Dam. And then finally what you see is a very high grade phase of gold with base metals at telluride at Sunrise Dam. Now, the key point here is you've got different kinematics and different alteration for these different events, right? So picking one phase of kinematics is not necessarily going to work in these systems, because you can see there's a phase of extension, east-west compression, sinistral slip and dextral slip in these systems, each with phases of mineralisation. Some are more endowed than others. Certainly this event here, which is called the orogenic gold event at 2650, is certainly, in terms of endowment, is probably the largest. If you look at Wallaby, so we're looking at the Wallaby space-time diagram here. I'll bring that up again in a second. So what happens when you have a history like this? You end up with papers published in exactly the same journal that say completely the opposite in terms of the genetic model for the deposit. So the top paper is linking the Wallaby deposit directly to the intrusion, and if you read the lower paper, which has a question mark, but I can assure you there's no question mark in that paper, they're very definite in saying that the gold at Wallaby is an orogenic overprint on magmatic hydrothermal pipe. So basically completely different models published in the same journal. So what we're looking at here is an oblique view viewed in Fraxis, if anyone remember Fraxis. Fantastic piece of software that Nick Archibald was a key person in developing. So what you can see here is an oblique view of the pit, and here the red is the syenite body coming up, and the pit's interesting because it actually is the top of the syenite body, so you can really see a lot of the different alteration types. And what you can see in purple here is a very oxidised phase of mineralisation, which is called the 50 series lode, and this gets cross-cut by a later set of these 240 lodes. And when you slice this and you map it underground, it's very consistent relationships between these green lodes, which are reduced, they don't have hematite, and these purple lodes here, which are oxidised. On this diagram here, you can see here's your syenite coming in. This is all your oxidised assemblages that are predominantly linked to this phase of deformation, and then it all gets overprinted by these strike-slip lodes. If you read the paper, Cellier dated the high-grade lodes at Wallaby. I've actually put the drill holes in that he sampled, and he actually sampled this lode and this lode here, which are the later phases of cross-cutting structures. So he got a 2650 age plus or minus 6, and then dated the cyanite, which he said was older, and in actual fact he's correct. So you can very clearly see, yeah, he has dated those lodes and they are not within age of the intrusions. And that was the key argument that Cellier put forward to not relate the lodes to the mineralisation. Here's an example of the pit. You can see the pipe here, the cyanite pipe, and what you find around this is these, for want of a better word, early magmatic calcite veins. They have a very radial distribution. They're clearly linked to the intrusion. They have, if you read Cellier's paper, he says the same thing. The way they radiate actually follows the pipe, and these things can carry up to 2.5 grams of gold. So what you can see is around this intrusion, the first phase of gold you can see are actually low-grade veins radiating around the cyanite. Then what you see is a phase of hematite-associated lodes, which I showed in the pit, and these actually get cross-cut and offset by these later strike-slip lodes. The reason they're different colours, they're quite different alteration. The Zone 50 lodes are bright red. They were called the red lodes when the pit was mined by Placer. And green is there. It has a standard orogenic style. Just to argue for kinematics, I am a structural geologist, so I thought I'd put one in. There's a very nice example of the pit shells that Placer Dome produced with the sinistral slip kinematics, with a very nice example of the alteration type linked to that phase of mineralisation. So, what we think has probably happened here is you've had intrusion come into a system with the radial veins. You've had a very phase of oxidised mineralisation, which is almost certainly linked to the intrusion. Mueller's dated that with Remy and Osmind dating. And then what you see is a much younger phase of orogenic style lodes overprinting it, which are not related to the age of the cyanite, right? So take-home points is that actually, no, there is a phase of gold linked to intrusion. The pyrite work that was done at ANU has showed that there is a link to the intrusion. There's these very oxidised lodes that appear to be linked to it. There's these radial veins that definitely are, but then there's an overprint that isn't. So what's the key point here? Well, you can argue for an orogenic or a pollutant-associated model. The kinematics are different between the different events. So the real question is not what is the genetic model for the deposit, is why is this all focusing in the same spot? Why are you seeing this intrusive body come up into the same spot? Why are you getting this phase of oxidised minerals and these reduced minerals coming into that place? Incidentally, changes in kinematics in that deposit are linked to changes in alteration. So the evidence from that deposit, in my view, is that the different assemblages you see were not coeval, and it's not consistent with the fluid mixing model for Wallaby. This is a paper by McIntyre and Martin, and guess what? They're arguing that within the basin there's a big transform fault, and the Wallaby sits on a transform fault. Most of you would have seen this in lots of papers, Octetti. There's plenty of deposits around where people argue there's transfers. John Standing also mapped this area in a lot of detail, and John Standing found that you've got this chatterbox shear zone that probably projects underneath this Wallaby basin, which is in brown, and then what's happened is your Wallaby intrusive is utilising that deep-seated structure. Both cases, they're arguing for old fault architecture, either related to the Wallaby basin or in the substrate, is why you see the intrusion come in the first place, and it's why you see multiple phases of gold focusing into that point. So this is a really key understanding in the last decade, is the role of early architecture, and obviously lithospheric boundary was covered certainly by Groves. This is out of a paper by Richard Blewett in Precambrian research, and what he's doing is he's linking down the bottom here the famous Cassidy map where he's got the isotopic gradients, and he's arguing you've got an oblique phase of extension here, and what you do is you create all these oblique trending structures. If you remember, Groves had an argument about oblique trending features, and that basically is one of the key things that sets up the architecture of the system. The argument in this model is that the early architecture is a control on where the melts go and where the fluids go. you can have more than one phase of fluid fluxing up that critical bit of architecture, and indeed more than one phase of intrusion. So it's not uncommon to see an intrusive system in there. You might get a phase of oxidised fluids coming in, carrying gold, and a later reduced phase of fluids coming in that are also carrying gold, coming up the same pathway. Right? So in reality, very little work's been done on this in the last 4 years. Right? A lot of work in the goldfields has been on drilling out brownfields deposits, and not a lot of work thinking about what are the fundamental architectural features that we can map in the belts to actually work out what's going on. A lot of work on deposit scale, building better regional maps, which is great, and defining the major boundaries with MT surveys and things like that, but not really enough synthesis of what are the key controls. So this just is a nice figure by, on Leonora by Nicholas Thibault, and that just shows at the top early basin architecture with a transfer fault up here, and as you evolve all the way down you get intrusions coming in and you produce the current present day geometry at Leonora. So the argument is your fundamental architecture present at the time of greenstone and sediment deposition controls the original basin thickness, and it does then have a control on all the subsequent deformation events. The alternate model is to say it's all layer cake and there was no early control in the system at all, which I think is probably unreasonable. Okay, so now I thought I had 30 on the thing. Yeah, it started late, so I've got my stopwatch going. St Ives is on a bend. I'll get through it. And what you can see at St Ives is, John talked about this, so I won't go too much into the overview, but this is the Bold-Lefroy fault here with the gravity. There's all these oblique trends cutting through the field. What are they? They certainly weren't on any structural maps originally, and John Walsh's team and Peter Newmeyer deserve credit for mapping those things out first, believe it or not, with alteration. They mapped out hematite phases and showed that there was some funny oblique trends in the system, which then ended up matching the gravity trends. So the actual alteration mapping did pick those structures up before the structural geologists. And just in here what you can see is the Bold-Lefroy fault, and that is an isopac map of the thickness of the ultramafics, which are at the very, not quite at the base, but pretty close to the base of the pole. And what was found by Karen Connors, who was an author on this paper, is that you have these oblique structural trends very similar to the regional model that Blewett had, and you had thickness increases linked to early faults in that system. But these were active very early in the system. The Capi slate, or the Widgeymorta chert, capped all of that. And so what you had is these early growth faults. They set up architecture, but then they were capped by these later sequences. And what you can see here is what that's done is it's created a feeder, but it's also created a superb trap, not trap, it's created a really fantastic seal in the system, and of course most of the deposits sit in this area. So if you go into one of these things, this is what they look like for real. This is the transfer fault in the pit, Agamemnon South, very high grade. These are a set of structures that come in and terminate against it. And what you see, once again, similar to Wallaby, on this transfer, oxidised fluids, reduced hematite-associated assemblages, overprinted by this reduced phase. And what you get is reactivation of those segments, and that there is basically the pathway that brings in the fluids. And it's active early and late in the system. It's active during the volcanism, when you have oxidised fluids in and when you have reduced fluids coming in. So what you see there is a very high level of complexity, and I walked Rail, the group geologist for Goldfields, through this pit, and he was shaking his head going, this is really, really complex. And so that's, you see a lot of complexity above those zones, and that's been shown by people like Hodkiewicz, where he's made fault complexity maps of the Yilgarn, and what you see is a link to complexity and deposits. And the interpretation is that those high levels of complexity are actually linked to early architecture in the system. And so, just to summarise, the complexity is really critical. Deposits are complex, commonly multiple generational, with multiple phases of gold-bearing fluids and intrusions. A lot of these irresolvable debates, I would argue it's just a function of sitting on top of a bit of old architecture that gets reactivated multiple times. Architecturally favourable zones are linked to complexity, and you can map these with structure, geochemistry, and also intrusive histories. They're really important. They're critical because you can map them. These are features you can map, particularly with geophysics. And there's a clear link with the mafic intrusives to the system. There needs to be more work done on understanding how the magmatism fits into the overall gold story. Too many studies have been, I'm going to prove that gold is or isn't linked to this deposit, rather than stepping back a scale and working out what are the fundamental changes in the system. So finally, things that we need to focus on is getting the timescales right, the timing of all the elements, mapping the architecture to regional to lithospheric scale with geology, geophysics and geochemistry. Got to map the real pathways here, right? So not just structures and kinematic events. The real question is how did the fluids move through these systems? Big low angle loads at Wallaby, how did the fluids move from one big flat structure to the next? It's not actually being worked out. As I said, focusing how magmatism fits into the gold mineral system. And there's a lot of similarities to places like the Permian. People who've worked in West Africa look at the switches in intrusive histories, look at the switches in the kinematics, look at the changes in the sedimentation, and there's a really remarkable amount of similarities in the system. And of course, finally, mapping where your prospective deep and shallow sources are. That's really not been touched on. So I hope I've been able to overview some of the controversies. I've got plenty of references in there that you can follow up on what I think are key papers to try and tease out what some of the key developments have been in the last decade. I think I'll leave it there. That's 29 minutes.
Thanks, John. Have we got a 29-second question?
John,
Right.
is there a date on Lancefield in the Leighton area?
I pass or can check through. Well, that was done by Norrie Wright, who went back to Germany. So there are dates on Agnew, which is involved, so you can check. We dated Zonggang, there's a bunch of new ages coming out that identified things like Crusader and Zonggang were actually older systems linked to the magmatic history, and the stuff you see at New Holland and the Kimloy are actually the younger central and dextral overprints. So yeah, we have identified pretty clearly a phase of